Hey, this is a video on reading a scientific paper. We're going to go through 10 tips. This will be useful if you've never read a paper before, so this can help you develop your first approach ever to reading a scientific paper. But it could also be helpful if you're just looking for some new ideas for ways to improve your process or your approach to reading a scientific paper. And so because I'm a psychologist, this will undoubtedly have some psychology type leanings to it. But these are going to be skills that can be used across all scientific academic disciplines, from social sciences to hard sciences. It's quite generalized. And the reason for that is that I've based all this on a paper written by Maureen Carey, Kevin Steiner, and William Petrie Jr. In PLOS Computational Biology. So these are all I'm not sure if they're all physicians, but they're medical researchers at the University of Virginia. I'm also, by the way, not sure if I have the right photo of Kevin Steiner. If he ever finds this, and that's the wrong photo, sorry, send me a picture of yourself so I can make that correct. But anyway, these folks wrote this excellent paper very recently, an editorial on rules for reading a scientific paper that I'm basically just going to take you through. I think it's helpful to talk about out loud, but you could alternatively just download and read the paper yourself. You'll see the DOI for the paper on the next slide. So let's do it. Start with number 1. Decide your goal in reading the paper. All right, you've got a paper, you printed it out, or you open the PDF. What do you want to get out of it? You might prioritize different parts of the same article differently based on your goals as a reader. So in this 10 Simple Rules article, they give us a couple examples. Let's say you're new to reading papers, so your priority might be to focus particularly on the figures so that you can try to get the most you can out of the data in the article. Or let's say you're entering a new field and you want to know what's important in that field. You might focus very clearly on the motivation for the study and the next steps that the authors outline at the end of the paper. Or how about, for an example not in this table, you might be reading a paper for the review you're going to write. So you're going to need to write a summary, and you're going to need to use the conclusion of it in a logical progression with other arguments. Perhaps you've watched some of my related videos and are building an argument in a psychological paper. And in that case, you're going to need to pull an important piece from every section, a reasonably short but comprehensive sentence or two that describes the whole section. And then you're also going to need to have an accurate interpretation of the outcome of the study so that you can then integrate it into your paper. So step 1 again, what's your goal? By the way, there's the DOI down in the bottom. If you enter https://doi.org and then put all this in there, you will see this paper. Step 2, figure out the author's goal. So you've thought about your goal. What is their goal? To help you interpret what they came out with, you should really have an idea what their goal was. And in the realm of interpretation, you might interpret the data that they show you one way, and they might interpret it another way. And figuring out the difference between those two can help you think about what their goal might be. Or vice versa, knowing their goal might help you think about why you have different interpretations of the data. So the clearest indication of the goal of the author is the type of article you're reading. So the list of article types is for a different video. It's in the paper if you want. But let's say you're reading a review article. Their goal might be to convince you that there is a particular way forward in some literature. If you're reading an empirical article, the goal is usually pretty simply to present some new data. So that's a nice, easy, interpretable one. The goals can be varying from there. You might be reading a commentary, or you might be reading a meta-analysis or any other kind of article. That's all going to have different goals. You can also work on what the author's goal might be by looking up who they are. What are their scientific interests, and how does this paper fit into their interests? Is it part of a long program they've had going, or is it a kind of new idea that they're exploring? That might help you think about their use of their data or their interpretation of their data. Keep in mind that all of these will be kind of tough when you're new to reading scientific articles, but I think this one in particular out of these 10 is tough when you're new to a field. It's the kind of thing that gets easier with experience, so don't bang your head against the wall too much trying to figure this out if you feel like you can't right away. Carrie et al. Give us 6 questions to ask of any paper. Number 1, what do the authors want to know? What is their research question? What did they do to try to answer that question? Why did they do it that way? What is the context of that answer to that question within their field of research? What do their results show? What do their figures show us? What's in their data tables? How did they interpret the data and the results? And lastly, what should be done next? If you're in a class of mine in which you write summaries, you probably see this list as quite familiar. The new piece here that I don't always talk about is maybe that context piece. Really nice, important one to add. Regarding that last one, by the way, what's next? You could consider what the authors pose is next, but it's also a nice place to try to start asking yourself some of these questions. What do you think should come next? What's the next study in this line of research if you were the researcher? So the beauty of these 6 questions is that you could ask them of the whole paper as one piece, but you could also kind of zoom in and ask all 6 questions of one figure or of one section. That would take a while, of course, but it would be worth it. And the process of asking each question in each section of a paper is something that you'll get better at with time and practice. Number 4, look very deeply at the figures and tables. Particularly if you are reading an empirical article, the primary purpose of that article is to show you the data. The reason those authors wrote that paper was to tell other people about the data they collected. And so in order for them to explain and show the data, they put together some figures and tables. So you should look deeply at what they put in them and how they put them together. So what's in them, what might be missing from them, how they're presented, what story they tell. Some people recommend you look at the figures first and then you read the text of the results section. Some recommend you do the opposite. I'll say that any combo of one or the other or something in between is fine, as long as you do what makes most sense to you. It's something that you'll probably develop a preference for as you read more and more scientific articles. But look at the axes. What are they? What are their labels? What values are on them? What colors did they choose? Are the colors meaningful? Is the separation of colors useful? Are they showing you any statistics they ran, or are they just showing you data, raw data? Why did they pick the type of graph they did? It's a scatter plot. Why is it a scatter plot and not a bar graph? All those kinds of thoughts can help you think more deeply about what's being shown. I already said this, but is anything missing? Is there any piece of data that you'd like to see graphed that isn't? And lastly, what's the take-home message? Because later you'll want to be able to compare your takeaway from the figures to the author's takeaway from the paper and note whether they're the same. Rule 5, pay attention to the sections. They've got a nice table in the paper that you could pause and look at here or go to the paper and look at to understand them a little bit more deeply if you don't already. But there are some sections that are intended to be objective, others that are intended to present interpretations. But even the objective sections are written by people and thus influenced by the people writing them. If you want to go even deeper than just these sections, the For Authors page on any journal's website will describe what they see as descriptions of each section of a published paper. So particularly if they have a section you're not familiar with, something like General Audience Summary, that was in a paper I recently published. If you want to know the difference between that and an abstract, you could look at the paper you're reading, but you also might need to go back to the journal's website to get those definitions to make sure you know exactly what you're looking at. So I already started saying that the interpretation of the author is going to be part and parcel to what you're reading, and that's true, and it is often the first thing to think about when you start to critique the article. No paper is truth etched in stone. Thought it was kind of ironic to directly quote that little piece, but I liked it quite a lot from the Carey paper. But remember, scientists are people, and as such, they have perspectives. They might overlook something in their paper. They might miss a potential other explanation, and you might want to think about whether, let's say they give their interpretation and explanation of the data, they outline another, maybe you can think of a third that they don't even mention. Maybe you find the second one more compelling and think that's the one they should have used. So think about whether you see assumptions in the writing, or whether what you know about the authors might lead you to believe there might be assumptions in the writing, or whether when reading you find yourself investigating your own assumptions. That'd be a cool piece of writing that got you to investigate your own assumptions. Maybe that can happen, and that can help you critique the article as you go along. Number 7, though I'm encouraging you to critique, also remember that in addition to being people and therefore fallible, all of us are people and therefore fallible. So understand that things that look really wrong at first read might just be differences in writing style, might be just typos that you're kind of missing. And most often, papers represent years and years of work for somebody. So if you want to write them about an error you think you found, be really, really nice, because it can be hard to not feel attacked on the other end of an email like that. On the other hand, if you ever want to write someone about how awesome a paper is, I would say don't hesitate. People love to hear about how great their work is. Rule 8. This is a long process. Reading an article is long. Learning to read an article is really long. Be prepared for how tough that can be. As you read, you might have to look up a bunch of stuff. Words, terms, whole literatures. You might need to download the supplemental materials and look at the other data they collected so that you can figure out an answer to a specific issue you have. Or, oh my goodness, you might need to read another paper to fully understand this paper. All science exists in a timeline. You can't just read one paper and know everything there is to know about a literature. You're going to have to read a couple probably, particularly if you are about to present an article in class. It can be really, really helpful for the people you're presenting to if you've read a couple papers near to the paper you're presenting, so that you can give some of that context that people might not have who've only read this paper. Some folks recommend reading every article 3 times. First, not really worrying about understanding, just sort of letting each word go into and out of your head. Second reading, deep for understanding. Third reading, even deeper, in which you look up whatever you need to, or take notes on things that you want to take away. But again, essentially, this is a long process, especially when you're new to it. Don't start reading the night before you need something read. Don't start doing research the night before you need something written. You will not be able to read things as fully as you need. Here's an idea. If you've read something and you're not sure whether you fully understand it, look for a chance to teach it, because if you can't tell someone else about it, you don't fully understand it yet. You could do that on any number of levels. You could tell somebody the big takeaways. You could tell somebody else the methodology, or you could dig into the minutia with somebody who is on a similar expertise level as you, like a classmate or your professor. We're always available for these kinds of conversations, because they both help you practice the information and help you find gaps in your knowledge. So when you try to have a conversation about a paper, when you find yourself hitting on one of those gaps, you know what to look for next time you go back and reread. And the last suggestion from our authors here is to build on it. They mean that in a couple of ways. Number 1, build on what you just read by reading more. Read the next paper in the line of research, or read an adjacent paper in the theory. but also build on it by doing your own thinking. Draw some of your own conclusions, link what you read to your own previous knowledge. Try even, I suggest, to find a similarity with any other thing you're working on. If you're writing a paper in social psych and cognitive psych, you can probably find connections between the two, even if they seem tangential. All these research areas are quite close together when you really zoom out and think about them. And that's true within psychology and interdisciplinarily as well. You can find connections between psych papers and topics in education, criminology, health, and so on and so on. This process of reading a scientific paper might sound intimidating. Remember that you don't need to do all 10 of these things every single time you read a paper. You should seek to add one by one until you can do all of them when you read a paper, but you shouldn't be spending days and days on a single paper for a single course. Try to find a way to get through the paper using some of these tactics within the scope of your regular work time. And all that said, allot the amount of time that you're going to need. Start early, start ahead of time. Don't try to read it the night before. And if possible, work with other folks. Talk to your classmates, talk to your professor. We're around to help you figure out what you're reading and what you're going to take from it. So I wish you good luck in reading some of your first scientific articles. Thanks for watching the video.